Module 8A is illustrating polynomial equations using synthetic division. The objectives are, first, to illustrate polynomial equations using synthetic division. Second, to find the roots of polynomial equation using, first, zero product property, and second, synthetic division. Now remember, the roots of a polynomial equation in x are the values of x that satisfy the equation. Next, to find the roots of a polynomial equation, we may, number 1, apply zero product property. That is, if a times b is equal to 0, then either a is equal to 0 or b is equal to 0 or both. Second, use synthetic division. So let's proceed with some examples. Find roots of the following polynomial equation. So we have number 1, x times x plus 3 times 2x minus 1 equal to 0. Now if the polynomial equation is in factored form, then it is easy to find the roots. All you have to do is to apply the zero product property. So let's start. So for x, this is simply x equal to 0. Now for x plus 3, we have x plus 3 equal to 0. Therefore, x is equal to negative 3. And last, we have 2x minus 1 equal to 0. We have 2x equals 1. So dividing both sides by 2, we have now x equals 1/2. Therefore, the roots for number 1 are 0, negative 3, and positive 1/2. Next, let's proceed with number 2. Find the roots of x plus 5 times x squared minus 4 times x minus 3 squared equal to 0. Again, notice that it is in factored form, so we just apply the zero product property. So you have x plus 5 equal to 0. Therefore, x is equal to negative 5. Next, we have x squared minus 4 equal to 0, and we say x squared is equal to positive 4. So getting the roots of both sides, or getting the square root, we have x now is equal to positive and negative 2. Last, we have x minus 3 equal to 0. Therefore, x is equal to positive 3. Now, what are the roots? So, the roots are negative 5, positive 2, negative 2. But recall that x minus 3 is quantity squared. So, we write 3 multiplicity two. So when you say multiplicity, it simply means that 3 is repeated 2 times. Next, we go to example number 3. So for number 3, notice that we cannot apply the zero product property. So what we're going to do is to factor or use factoring by grouping. So let us try to group x cubed and negative 9x. Then we group 6x squared and negative 54. Again, that is equal to 0. Now, factoring out the common factor, we have x. So, we have here x squared minus 9. Plus, the common factor of 6 and 54 is 6. So we have x squared minus 9 equal to 0. Now simplifying them, we have x plus 6 times x squared minus 9. And that is equal to 0. And since it is now already in factored form, we can now apply the zero product property. So in this side, we have x equals negative 6. Well, this one, we have x squared minus 9 equal to 0. Again, let us get the square root of both sides. Therefore, x is equal to positive and negative 3. Therefore, the roots for number 3 are negative 6, positive 3, and negative 3. Okay, let's proceed with example 4. So we have x cubed plus x squared minus 10x plus 8 equal to 0. So notice that it is quite difficult to factor a cubic polynomial. So let us try to use synthetic division. Now, in using synthetic division, we need to find the value of x that would make the equation equal, or the remainder equal to 0. So let's start. So we have here 1, 1, negative 10, and positive 8. So for our trial divisor, we are going to use the factors of 8. So it can be 1, 2, 4, or 8. So let's try to use 1. So bring down 1. 1 plus 1 is, 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. We have negative 8. Negative 8 times 1 is negative 8. And there we have it. Our remainder is 0. So again, another trial divisor. So let's try to use 2. So bring down 1. 1 times 2 is 2. 2 plus 2 is 4. 4 times 2 is 8. Negative 8 plus 8. And we have a remainder of 0. Now for the last factor, we have x plus 4 equal to 0. Therefore, x is equal to negative 4. So the roots are 1, positive 2, and negative 4. Now, for our last example, the product of 3 consecutive integers is 210. Find the integers. So, let's look at the problem. So, when we say consecutive, ibig sabihin, magkakasunod. So, we are going to start with representing the problem. Let's say that our first integer is x. Therefore, the second is x plus 1. And the third one is x plus 2. Now, what about the equation? So, the problem states that it is the product. So, our equation is x times x plus 1 times x plus 2 equal to 0. So, let us try to solve. Or rather, equal to 210. Now, let us multiply or get our polynomial equation. So, let us first multiply the two binomial. So, that is x times, using the FOIL method, we have x squared plus, this one is x plus 2x, you have 3x. Then 1 times 2 is 2 equals 210. Now, distributing x to all the terms of the equation, we have x cubed plus 3x squared plus 2x transpose 210, and that is equal to 0. Now let us use synthetic division. So we have here 1, 3, 2, negative 210. Now let's have our trial divisor. So let's try for 5. So bringing down 1 times 5 is 5. 3 plus 5 is 8. 8 times 5 is 40. We have 42. 42 times 5, so 2 times 5 is 10, carry 1. 5 times 4 is 20 plus 1. And you have it. We have our factor. So x now is equal to 5. So the second number is 6. And the third is 7. So let's check. Is 5 times 6 times 7 equal to 210? So 5 times 6 is 30 times 7, so that is 210. So the three consecutive integers whose product, or the product of three consecutive integers is 210s are 5, 6, and 7. Module 8b is all about illustrating polynomial equations using remainder theorem. The objectives are to illustrate polynomial equations using the remainder theorem and to find the roots of a polynomial equation using the remainder theorem. Now remember, the remainder theorem states that if a polynomial p of x is divided by a linear binomial x minus r, the remainder r is a constant and is equal to p of r. Proceed with example 1. Find the remainder when p of x is equal to x to the fifth minus 3x squared plus 2x minus 1 is divided by x minus 2 using the remainder theorem. Now notice that since x minus 2 is already in the form x minus r, then we can say that x or r is equal to 2. Now using the remainder theorem, we say that p of 2 is equal to x to the fifth minus 3x squared plus 2x minus 1. So what do? We substitute 2 to all the values of x in all the terms. So we have here 2 raised to 5 minus 3 times 2 squared plus 2 times 2 minus 1. So what is 2 raised to 5? It is 32. Minus 2 squared is 4 times 3, we have 12. 2 times 2 is 4 minus 1. Now what is 32 plus 4? So we have 36. Negative 12 minus 1 is negative 13. Therefore, p of 2 now is equal to 23. So what is this 23? 23 now is our remainder. So, when p of x is divided by x minus 2, then the remainder is 23. Next. Let's go to example 2. Use the remainder theorem to find the remainder when p of x equals x cubed minus 5x plus 7 is divided by 2x minus 3. So again, let us rewrite 2x minus 3 or get the value of x. So we have here 2x minus 3 equal to 0. So 2x is equal to 3, divided both sides by 2. So x is 3 halves. So using the remainder theorem, we have p of 3 halves equals to x cubed minus 5x plus 7. Doing the same with number 1, substitute 3 halves. So we have 3 halves raised to 3 minus 5 times 3 halves plus 7. So 3 raised to 3 is 27. 2 raised to 3 is 8 minus 5 times 3 is 15 over 2 plus 7. Now, to simplify, we get the LCD. That is 8. So, just copy 27 minus 8 divided by 2 is 4 times 15 is 60. 8 times 7 is 56. So, simplifying, we have 27 plus 56 is 83 minus 60 over 8. Therefore, P of 3 halves is equal to 23 over 8. Or we say that the remainder is 23 over 8 when x cubed minus 5x plus 7 is divided by 2x minus 3. Go to number 3. What is the value of k so that when p of x equals 3x cubed plus 5x squared plus kx minus 10 is divided by x plus 2, the remainder is negative 6. So, by the remainder theorem, we can say that p of negative 2 is equal to negative 6. That is, substituting negative 2 to all the x, we have p of negative 2 now is equal to 3 times negative 2 cubed plus 5 times negative 2 squared plus k times negative 2 minus 10. But what is p of negative 2? It is negative 6. So, solving for it, we have 3 times negative 2 cubed is equal to negative 8 plus 5 times negative 2 squared is 4 minus 2k minus 10. Again, it is equal to negative 6. So, solving for it, we have negative 24 plus 20 minus 2k minus 10 equals negative 6. So, combining like terms, we have negative 24 minus 10, that is negative 34 plus 20 minus 2k equals negative 6. So, this is negative 14. Transposing it, we have negative 2k equal to negative 6 plus 14. So, negative 2k now is equal to positive 8. So, divide both sides by negative 2. So, k now is negative 4. Number 4. Using remainder theorem, determine which of the following is a root of the polynomial equation 2x to the 5th minus 8x squared plus 6 equal to 0. So we have two givens of x, so that is a, x is equal to negative 1, and for b, we have x equals 1. So by applying the remainder theorem, we simply substitute the given values of x and check which of the two satisfies the polynomial equation. So let's start with letter A. So for x equals -1, we have p of -1 is equal to 2 times -1 to the fifth minus 8 times -1 squared plus 6 equal to 0. So that is 2 times -1. -1 squared is positive times negative, that is still -8 plus 6 equal to 0. So what is 2 times -1? That is -2. -8 times 1, that's -8, plus 6 equals 0. So -2 minus 8 is -10, plus 6, that's -4. Therefore, x equals -1 is not a root of the polynomial equation. Next, we go to letter B. Let us now get p of 1. So for p of 1, that is 2 times 1 raised to 5 minus 8 times 1 raised to 2 plus 6. So this is 2 times 1 minus 8 times 1 plus 6. So what is 2 times 1? That is 2. Minus 8 plus 6, is it equal to 0? So 2 plus 6 is 8. Minus 8 is 0. Therefore, for x equals to 1, it is a root of the polynomial equation 2x to the fifth minus 8x squared plus 6.
Module 8C is all about illustrating polynomial equations using factor theorem. So the objectives are to illustrate polynomial equations using factor theorem. Second, to find the factors and roots of polynomial equations using factor theorem. And finally, to find the polynomial equation given its roots using factor theorem. Now, the factor theorem states that the polynomial p of x has x minus r as a factor if and only if p of r is equal to 0.
Start with example 1. Show that x plus 3 is a factor of p of x equals to x cubed plus 2x squared minus 5x minus 6 using the factor theorem. Now, the factor theorem is a special case of remainder theorem. Using the remainder theorem, we check if p of -3 is equal to 0. So let's start. So getting p of -3, we have -3 cubed plus 2 times -3 squared minus 5 times -3 minus 6. So this would become -3 cubed, or negative raised to an odd is negative. -3 squared is positive 9 times 2, that is 18. -5 times -3 is positive 15, and that is minus 6. So -27 and -6 is equal to -33, while 18 plus 15 is positive 33. Therefore, p of -3 is equal to 0. Since the remainder is 0, then we say that x plus 3 is a factor of p of x. Now, aside from the remainder or the factor theorem, we can also check using synthetic division. That is, we have to look if the remainder is 0.
So using synthetic division, we have 1, 2, negative 5, negative 6, and our divisor is negative 3. So bringing down 1, 1 times negative 3 is negative 3. 2 plus negative 3 is negative 1. Negative times a negative is positive. Negative 5 plus 3 is negative 2. Negative times negative is positive 6. And we have a remainder of 0. So they have the same result. Okay, let's go to number 2. One factor of a polynomial equation x cubed plus x squared minus 10x plus 8 equals 0 is x minus 2. Find the other factors. Use the factors to determine the root. Now, the roots of a polynomial equation are related to its factor. This is the premise of the factor theorem. Once you've identified the factors, it will be easy for you to identify the roots or vice versa. Since x minus 2 is a factor of x cubed plus x squared minus 10x plus 8, then we can say that x equals 2 is a root of the equation. So let us verify using synthetic division or remainder theorem. So we have here 1, 1, negative 10, and 8. So we use positive 2. So bringing down 1, we have 1. 1 times 2 is 2. 1 plus 2 is 3. 3 times 2 is 6. So you have negative 10 plus 6 is negative 4. 2 times negative 4 is negative 8, and that is 0. Now, these numbers 1, 3, and negative 4 are called the depressed equation. Okay, so we call this the depressed. So we are going to work on this depressed equation by writing it as an trinomial. So this can be written as x squared plus 3x minus 4 equal to 0. So let us factor completely. So we have here x and x equal to 0. So we have 4 and 1. So 4 minus 1 will get 3. But the sign of 3 is positive. So we put positive here, and this one is negative. Therefore, the other factors are x plus 4 equal to 0, or x is negative 4. On the other side, we have x minus 1 equal to 0, and x equals 1. Now, you can rewrite the equation as, or in factored form. So that is x minus 2, or rather p of x, is equal to x minus 2, x plus 4, and x minus 1. So, for example 3, find the polynomial equation whose roots are negative 4, negative 2, and 1. So, notice that this is working the other way around. Baliktad naman tayo. With the factor theorem, it is understood that the roots are x equals to negative 4, x equals to negative 2, and x is equal to 1. So, we can express this as a factor in the form x plus 4, x plus 2, and x minus 1. Then that is equal to 0. So let us just multiply. So x plus 4 times x plus 2 by the FOIL method is x squared plus 6x plus 8 times x minus 1 equal to 0. Then work one by one. So start with x. X times x squared is x cubed
plus x times 6x is 6x squared. X times 8 is 8x. Then we proceed with negative 1. Negative 1 times x squared is negative x squared. Negative 1 times 6x is negative 6x. And negative 1 times 8 is negative 8. That is equal to 0. So let us simplify. So bring down x cubed. 6x squared minus x squared is 5x squared. 8x minus 6x is 2x. Then just copy minus 8. Therefore, our polynomial is p of x equals x cubed plus 5x squared plus 2x minus 8. Module 8D is illustrating polynomial equations using rational root theorem. Now, the objectives are to illustrate polynomial equations using rational root theorem. Second, to list the possible rational roots of a polynomial equation using the rational root theorem. And third, to find the rational roots of a polynomial equation using the rational root theorem and synthetic division. Now, the rational root theorem states that the possible rational roots of a polynomial p of x are of the form p over q, where p are factors of the constant term and q are factors of the leading coefficient. Okay, let's go to example 1 of the rational root theorem. So, use the rational root theorem to find the possible roots of the polynomial equation. So, since in example 1, you were only asked to find the possible roots, then we are not going to solve. So, let's start with letter A. X to the fifth minus 6x squared plus 4 equal to 0. So, based on the rational root theorem, we have to find P. And what is P? It is the factors of the constant term or 4. So, what are the factors of 4? So, let's start with positive and negative 1, positive and negative 2, then you have positive and negative 4. Next, let us find Q. So, Q comes from the factors of our leading coefficient. In this case, it is 1. So, what are the factors of 1? It is simply positive, negative 1. So, if your Q is 1, then the possible roots of the polynomial equation is simply, or P over Q, would be equal to positive, negative 1, positive, negative 2, and positive, negative 4. So, these are the possible roots of your polynomial equation x to the fifth minus 6x squared plus 4. Next, let's go to example B. So, for B, our P is negative 9. Again, start with the smallest factor. So, that is 1, positive, negative 1, positive, negative 3, and positive, negative 9. Next, let's get the factors of Q. Our Q is positive 2, or the factors of the leading coefficient. So, in this case, we have positive and negative 1, positive and negative 2. Now, I always say that for you, to make it simple in getting P over Q, then do it systematically. start with 1. 1 divided by 1 is positive negative 1. 1 divided by 2 is positive negative 1 half. Now, you are done with 1. Tapos na tayo dyan. Punta naman tayo kay 3. 3 divided by 1 is positive negative 3. While 3 divided by 2 is positive negative 3 halves. Then, proceed with 9. 9 divided by 1 is positive negative 9. While 9 divided by 2 is positive negative 9 over 2. And we are done. So, the possible roots of 2x cubed minus 6x squared minus x minus 9 are positive negative 1, positive negative 1 half, positive negative 3, positive negative 3 halves, positive negative 9, and positive negative 9 over 2. So, mga anak, possible roots pa lang yan. Hindi pa tayo nag-solve. Now, let's proceed with example 2. Now, in example 2, you are now asked to find all the rational roots of 2x to the 4th minus 3x cubed minus 33x squared minus 13x plus 15 using the rational root theorem. So, gamitin natin ang paghahanap ng mga possible roots. So, again, you have P. Our P is 15. So, we have plus minus 1, plus minus 3, plus minus 5, and plus minus 15. Now, for Q, you have positive 2. Again, that is plus minus 1 and plus minus 2. Now, what is our possible divisor? So, you have, start with 1, positive negative 1, positive negative 1 half, positive negative 3. Then, you have 3 over 2. Then, proceed with 5. 5 divided by 1 is 5. 5 divided by 2 is 5 halves. And the last one, 15 divided by 1 is plus minus 15. And 15 divided by 2 is plus minus 15 over 2. So, what do you notice, class? Ang dami. Kaya dapat, samahan ninyo ng konting magic. Kailangan daw, makahula kagad tayo. Now, notice the degree of our polynomial equation. By the fundamental theorem of algebra, it is stated that at most, the number of zeros or the number of roots is equal to 4. Okay? So, that is at most, ang expected natin ay 4 na rational root. Bakit at most? Kasi pwedeng hindi lahat ay rational. So, let's start. Using synthetic division, let us try to find the roots of our equation. So, ano gusto ninyong gamitin sa mga listahan natin? Try natin si 1. So, we have 2, 2, negative 1, negative 1, negative 34. Then, you have negative. So, lumalaki lang. What about negative 1? So, this is negative 2, negative 5, positive 5. What is negative 33 plus 5? So that is negative 28. Then, positive 28. You have 15 times negative 1. So, you have negative 15. O, class, may isa na tayong root. That is negative 1. Next. Let's try another. So, we have here 1/2. Pwede ba ang 1/2? So, you have 2. 2 times 1 is 2 divided by 2 is 1. Negative 4. Negative 4 divided by 2 is negative 2. 28, or rather negative 28 plus negative 2 is negative 30. Negative 30 divided by 2 is negative 15. Ayan, sinuswerte tayo, class. Tama ang hula natin. Another. You can also notice that this is already what we call the depressed equation. So, let's try to factor para mas mabilis. So, you have 2x squared minus 4x minus 30 equal to 0. Next. So, ano ba yung factors nila? So, pwedeng 6 and 5 or 15 and 2. So, let's try 6 and 5. So, kung 2x to, x to. Pag 6 dito, magiging 12. Pag 5 to, magiging 10. 6 to, 10 minus 6 is 4. So, tama. So, ito si 5. Ito si 6. Pero, negative yun. So, dito si negative, dito si positive. Equal to 0. Now, let's get the value of x. 2x plus 6 equal to 0. So, that is 2x equals negative 6. So, dividing both sides by 2, we have x is negative 3. And last one, we have x equals 5. So, what are the roots? So, you have 1, negative 1, 1/2, negative 3, and 5. So, notice that all the roots of our equations are rational.